Hello, my viewers. My name is Siri Menekpenyong with Sunday, and I welcome you all to my YouTube channel on PU Foam Academy. And this is a academy that work with my own professional experience. Now, so far so good. In my presentation today, we shall be looking at what is on the board, the geography of PU forming a process 2. The last presentation was lesson 26. It was just the introductory part of it about the geography of PU forming a process. Like today is going to be in the same topic, but part 2 of the geography of PU forming process. And taking us back to what we did in our last lesson or presentation was that when we say the geography of PU foam process, you are looking at the PU foam reaction and the change in atmospheric weather conditions and that of the boiling point of water. And these two key factors affect how water react and how gases behave during forming. And I did say that there is what we call factory location. Factory location. Factory location means where the forming plant is situated. And this location varies from places to places. And that is why I keep saying in forming process that there is no way one can copy PU foam formulation, because the formulation that work efficiently in China cannot work in Nigeria because of what this environmental atmospheric or change in atmospheric condition, because you have all the processes to keep in place. So in that case, the forming engineer, there are certain factors that you are in charge, that you are under control. The other ones you don't have power. But what you need to know is to have a deep knowledge on how this environmental factor affects forming a reaction. That is most especially, we call it chemical kinetics. That is the speed at which the forming reaction proceed. As we all know, that the high density speed or the speed at which you are producing high density is quite different with the speed at which you produce the low density, because of the difference in the blowing agent that determine the density. Now, so what are we saying here? That is to say, we did define our factory location. The main factor is the altitude of your factory location, and this decreases as you are. That is what am I trying to say? Let me think of. Okay, let us first know what is meant by atmospheric pressure. Atmospheric pressure means the weight of air, the weight of air above us that is acting downward. And this weight of air varies from location to location. You understand? So in this case, it means that the, how do I put it? The altitude of a place decreases, okay? Decreases as you are changing the location, meaning that the higher you go, okay, the lower it will become. So what are we saying? We have a standard value of 101.3, okay, kPa. This is equal to 1 bar. You understand? That is the value of the standard atmospheric pressure. Now, this value is very, very important. Then one may ask, how do you know this value? This value, you can easily measure it by the use of a machine called barometer of your factory location to know. So this is what we call at the sea level. At the sea level. So at the sea level, this is what you have. Now, supposing this value is going higher, we have something like this. This is a baseline. Okay, you have something like this. You have something like this. So this is 101.3 kPa. Now, in this case, is therefore mean this value is increasing or decreasing. So in this context, as a foam engineer, you must able to know about this value and how it affects PU foam or reaction process. Now, take a look at this. For example, most of you notice what I'm going to say now. When you are foaming, you want to produce a foam density of 22, for example. You want to produce a foam density of 22, right? Good. Now, at the end of the day, you design a well-balanced formulation that will give you this 22, whether it's a water-blown formulation or with methylene chloride. But at the end of the day, the foam density increased to 25. Okay. Now, in this case, you will notice that the speed of conveyor would reduce. You understand? So most people will say, oh, there's a problem of the machine. Let's calibrate the machine. Good. You may calibrate the machine. You will still have the same condition. By the time the block get to the cutoff, the weight of the block would increase above expectation. You understand? So in that case, the reaction will move very slow. Do you know what happened? Because there is a change in this value. This value is going higher. So this value has gone above 101.3 kPa. And that is why you have this condition. So in this condition, the gas expansion will be well restricted. You know, at a higher pressure, what happened to the gas molecule is that it's going to be compressed. So at that point, it's restricted. Okay, at a lower pressure, the gas will do what? Expand. So this high value above this sea level would affect the reaction by restricting how gas would expand. Okay, so in that case, the block weight or the expected block height of your foam would reduce. You will not get it, and the density will increase beyond expected density that you wanted to produce. I know some of you notice all these things. So some of those things is not about, well, the machine is not well calibrated, the chemical deliver more or no. That is to say, this is the major issue. So when you have such issue, don't blame the machine, you don't blame the polyol output, don't blame anything. This is what you notice. You understand? Now, how do you correct this? The best way to do this is that you have to increase your blowing agent. Okay, reduce water and increase the blowing agent, much especially the MC. But in this case, you want to still maintain this. So how do you know that this thing change? Is by you measuring this. You know, this simple explain what Boyle's law is all about. Am I right? What did Boyle's law tell us? Permit me to erase this because of time. I think Boyle's law says P1 V1 equal to P2 V2. So in this case, it's telling us increase in pressure decreases the volume. So at this one increases, this one decreases, but what happened to the temperature? The temperature remains constant. Now, in your foaming process, you will now discover that you have your temperature at 22/19 degrees centigrade. That's the temperature of the material. So in this concept, the temperature is not affected here. Okay, some people will say, oh, the temperature is too chill, let's increase it. No, it's because the atmospheric pressure of your factory location have increased above 101.3 kPa or 1 bar. That's why you have that kind of reaction. You understand? Is it not interesting? So you know that your pressure equal to force per unit area. Okay, so in that case, the gas in the foam system will be restricted. It will not expand well. It's going to have a limit, so it will compress. But in the reverse way, the foam would expand. In most cases of that type, you end up producing low density if you don't balance your reaction very well. So in a practical sense of this, it is important for every PU foam factory to have barometer. Barometer will help the foaming engineer to able to measure the altitude of the factory location, so that it will be able to control the reaction at a very normal process. And remember, this value, the 101.3 kPa to 1 bar, is the ideal condition. So in that case, you don't need any adjustment of the formulation. Everything will work well. It means that the atmospheric pressure is not going higher and it's not going lower. It's at the sea level. I told you, when one say at the sea level, okay, when we say the altitude is a place above the sea level. And what is the sea level? The sea level simply means 0 meter or meter. That is at the sea level. So that is the baseline at which your foaming reaction can be under controllable condition without giving you much headache. But when such value changes above or below, you need to adjust the formulation parameter. And how do you adjust it? For you to have a deep knowledge about how environmental and operational process change during foaming. Then you now see how you can correct them so that you have the best production process. You understand? Is it not very interesting? Because many people do not have much idea about the geography of the foaming process. And the geography of the foaming process, remember I just said that it affects how water, the boiling point of the water, that is changing the behavior of the water molecule that generates CO2 in the foaming reaction, and also how the gases behave by compression and expansion, and this affects PU foam physical property at the end of your production. So continue to subscribe to my channel on your notification bell so that whenever I upload a new video, you'll be notified. Keep watching. I love you, my viewers. Thank you. Bye bye.